Are you there? Hey, how you doing, guys? All right. Now, this video is going to have the last concepts that you need to learn from section 12.1. There are a couple exercise sets that might require me to make some videos just to show you some applications of concepts, but these are the final concepts that you need to know. All right, and there's two of them that we're going to talk about, and one is necessary for the other. The first thing we're going to do is that you're going to find a unit vector. Remember, that's a vector of length 1 that's in the direction of some other vector. So say you're given the vector 2i minus 3k, and you wanted to find a unit vector that went exactly the same direction. We're going to learn how to do that. And then the second goal is that you're going to find a vector of magnitude k in the direction of some vector. So say I take that same vector I mentioned a moment ago, I forgot what it was, but like 2i plus 3j. If I can make a vector, a unit vector in that direction, why can't I make a vector that's 9 units long or 20 units long or something? I can, and that's what we're going to be trying to accomplish here. We're going to start with that unit vector part. I've given you a vector v here on the screen, and we're going to try to find a unit vector that's in the direction of vector v. All right, now, when I say we're trying to find a unit vector, we're going to try to find either the column form or the unit vector form of a unit vector that's in that direction. Let's try the column vector form. And I'm going to go and write the column vector form for vector v to begin this process. What we need to accomplish is we need to find some way of altering these components so that their magnitude gives you a magnitude of 1 rather than the current magnitude. And the way that we're going to do that is we're actually going to have to find out what the magnitude of v is, and then use that to help us out. So let's find the magnitude of v. And for what we're doing here, I'm not going to worry too much about simplifying that radical, but that's the magnitude of v, correct? Now, this then, the vector here is the square root of 40 units long. If I wanted to reduce its length so it's 1 unit long, hopefully the thing that makes sense to you to do in order to accomplish that is you would divide this length by itself, right? If it turns out, if you take the components of a vector and you divide it by the magnitude of the vector, it gives the components of a vector that would be a unit vector that would go exactly the same direction. So watch this. All I'm going to do is say I'm multiplying the components here by the reciprocal of the magnitude of that vector. Now, I'm not actually going to do the multiplication. I'm just going to leave that as a scalar out there. But if I multiply negative 6 by 1 over the square root of 40, and I multiply negative 2 by 1 over the square root of 40, what that would do is scale down this vector so that it's only 1 unit long instead. Kind of cool. Here's the general form of what we just did right there. Generally speaking, if I want to find a unit vector in the direction of some other vector a, all I've got to do is take the components of a and divide by the magnitude of vector a. Guaranteed to give me a unit vector in that direction. And that can be accomplished similarly if you would just multiply vector a by the reciprocal of its magnitude. Those are the same thing, aren't they? All right, excellent. Now let's see if we could find a vector of any length we want to that's in the same direction as another vector. Going to be pretty simple if you understood what we just did a moment ago. We're going to try to find a vector here that's of magnitude 5 that's in the same direction as w. Now, just like before, I'm going to start off with finding out what the component form of w is, and then I'm going to try to modify that so that it's going to have a magnitude of 5. Now, listen to my thought process here. You already know how to take this vector and to whittle it down so that it's got a magnitude of 1, so that it's a unit vector in the same direction. Well, if you can make a magnitude of 1, you can make a magnitude of anything you want to. All right? If I want to make a magnitude of 5, all I have to do is multiply something that has a magnitude of 1 by 5, don't I? All right, so let's kind of do this. Let's go ahead and find a unit vector in the direction of w by finding w's magnitude. 1 squared plus negative 2 squared is 5, right? So the magnitude would be the square root of 5. And then multiplying w by the reciprocal of that. So 1 over the square root of 5 times the vector 1, negative 2 will give me a unit direction in the same unit vector in the same direction as w. Well, if I want to lengthen that so it has a vector of 5, a magnitude of 5 actually, is what I mean to say, all I really need to do is multiply that by 5 to make it happen. So watch. To make a vector of magnitude 5 in the direction of W, I'm going to multiply the unit vector in that direction by 5. Which basically just amounts to having that 5 over the magnitude times the original vector. Like this. All right, now to generalize that, multiply the unit vector in the direction of W by whatever scalar k you want the magnitude to be. So multiply k times a over the magnitude of a, or if you prefer, multiply k over the magnitude of a by the vector a. It looks pretty complicated, but I think you followed my reasoning there, and it's actually kind of a simple thing. One more note here before we do a couple more problems. You can do this whenever you write the vector in in column form like that, or I could have given the answer in unit vector form as well, and I want to write that in just to make sure you know it. And you need to be able to write it in that form or in this form right here. These are the answers for the example, so I'll make sure that's kind of indicated. Either one of those would work out. Alright, so some problems involving unit vectors in the direction of something. I want you to find a unit vector in the direction of the vector between these 2 points here, meaning you need to find out what is the vector between A and B, then find a unit vector in that direction. Go for it. There's a column form of vector AB. Remember to do B minus A in order to figure that out. Then let's find the magnitude of that vector. There you go. Remember how to do that for three-dimensional vectors, I believe. And then we're going to do 1 over that magnitude times this vector, and that will be the unit vector that we're looking for. Wish there was a short way of writing that, but there's not. Nevertheless, there's how you find that unit vector. Alright, one more problem which is not necessarily related to skill, but it's related to the unit vector concept. You ought to be able to take a vector and show that it is a unit vector if you're told that it's a unit vector. And so that's what I want to do here with this one. And it looks kind of tough because you got the fractions for your components. Nevertheless, let's show that the magnitude of this vector is 1. You can see I'm simply using the magnitude formula, the square root of a squared plus b squared. And I'm just working with fractions. And you can follow the rest of my work there, but we showed that its magnitude is 1. That shows that it's a unit vector. Alright, you've learned all the concepts for 12.1. Thank goodness, we got to the end, didn't we? Alright guys, we'll keep strong for the rest of this chapter. Thank you for watching again. See you later.